Hi, today's lesson is 5.3 Similar Triangles. The objective is how do we identify similar triangles and use similar triangles to solve problems. You've learned about congruent triangles where they have the same size, same angles, they're congruent, they're equal. But with similar triangles, you may have the same exact shape, like both of them are triangles, but they're similar because based on their proportions. So to prove that two triangles are similar, we must first show that, that all corresponding angles are congruent, and then second, all corresponding sides are proportional. So remember with congruent, the angles are congruent. Congruent triangles, the angles are congruent, the sides are congruent. But with similar triangles, the angles will be congruent, but the sides will be proportional. So it's almost like congruent triangles are like twins, and like identical twins, and similar triangles are like fraternal twins, or someone who's trying to dress like you, be like you, but they're not like you. You're similar because you're wearing the same clothes, you're trying to do the same thing, but you're similar in that way, but you're not congruent. All right, so there are rules, just like with congruency. There were rules, but with similar triangles, there are also rules to prove that the two triangles are similar. So for the first one, we have the angle-angle similarity, AA, and that little squiggly line that tells you that it's similar. So when it comes to that, you got angle-angle similarity. It states that if two angles of a triangle are congruent to two angles of another, then the two triangles are similar. So here we have that P and T are similar, are congruent, and Q and S are congruent. So then we can prove right away that these two triangles are similar with that little symbol. Then we have side-side-side similarity, and that's that little squiggly line that represents similarity. And it states that if all pairs in both triangles are in proportion, then the triangles are similar. Remember the key word, proportion. When you hear that the sides are in proportion, then you know that the triangles are similar. So we have here A is to AX is equal to B is to BX and is to C over CX. So these sides are in proportion. So whatever this triangle is, if you say we doubled it or tripled it to this size, it's in proportion. So that means these two triangles are similar. Then we have the side angle side similarity, SAS, and it states that if two pairs of corresponding sides are in proportion and their included angle, that means the angle in between the two sides, are congruent, then the two triangles are similar. So as you can see, we got A is in proportion to AX, C is in proportion to CX, and Q and S are congruent. When you see that, then you know that these two triangles are similar. And this will be at first confusing because you've learned about congruency where you have SSS, SAS, ASA, and SAA. So that's for congruent triangles, because when you have angles are congruent or sides are congruent, then you got the triangle congruency. But with this, we have three. We got AA similarity, SSS similarity, and SAS similarity. So that means that the sides are in proportion and the angles are congruent. So the only thing that's congruent is the angles, and the sides have to be in proportion for the two triangles to be similar. All right, so we're going to do examples based on the triangle similarity. Let me get the pen. So for the first one, it says in the figure, FG is congruent to EG, and BE is equal to 15, CF is equal to 20, and AE is equal to 9, and DF is equal to 12. determining which triangles in the figure are similar. All right, so there's a lot of measurements. They told us that two sides are congruent. So we can see that they already marked it up. So this and this are congruent. And now they gave us information. So in order to do this, what I would do to make my life easy is I would draw the two triangles separately. So that way I can see what I'm working with and what I'm marking up. All right, so I'm going to make this B, A, E, and then this one is C, F, D. And I know they had, put that, oops, did not click on that. So this part, so when they intersect, that would be G. And then they mentioned that those two little pieces are congruent. All right, so I separated them. Anytime you see triangles overlapping, connect in a certain way like that, try to separate them so that way you can have a better sense of what is going on. And I'm going to use red to label it. So that means BE. BE, that whole thing is 15. Then CF. You know what? I'm going to move that so I can give myself some space to work with. Oops. And that's going to. Alright, so never mind. Because then that means I'm going to have to erase whatever. Alright, so I'll just do the best I can with this. So this side is 20. AE is 9. DF is 12. Alright. So in the figure, they gave you all the information, and they wanted to determine which triangles in the figure are similar. So in order to figure out if they're similar, let's look at the sides. So I'm going to set it up so I have AE to DF, and then I have BE to CF. And I'm going to see if they are similar. That means the two ratios that are set equal to each other have to be in proportion, has to be equal to each other. So I'm going to use another color and then put in all the numbers representing this triangle. So I got AE, which is 9, then I have DF, which was 12, and then I have BE, which is 15, and then I have CF, which is 20. All right, and if I go any further, if I want to, I can either cross multiply or I'm going to reduce the fraction. So this one, what they have in common is 3, so then it'd be 3 over 4. And then this one, what they have in common, the greatest common factor is 5. So then that'd be 3 over 4. Yeah, the sides are in proportion, they're equal to each other, so the answer is yes. The triangles are similar. Yeah. So again, it's one side in ratio to the other side equal to the other side of the original triangle in proportion to the other side of the other triangle. If they're equal, then they are similar because they are in proportion. All right, so the next one, they didn't give us any numbers or anything. Let me make this, oops, let me go back to the full screen. Make this wider. All right, and let me scroll this down a little bit. So they said that determine whether each pair of triangles is similar and justify your answer. So they didn't give us any numbers or anything, but there's something, a clue that they're giving us. These arrowheads tell us that these two lines are parallel. And if we can go back to when we learned about special angle pairs with parallel lines in a transversal, we learned about corresponding angles, we learned about alternate exterior angles, and also linear pairs, all that stuff. But with these two triangles, so we have this triangle and then we have the bigger one. Parallel line. This is the transversal. These are two lines that are cutting through this transversal AC. I could say that this angle is congruent to this angle because of, so I'm going to just put angle B is congruent to angle A is congruent to angle B because corresponding angles. Corresponding angles. And what we learned about corresponding angles is that they are congruent. And it happens when you have two parallel lines cut by a transversal. Now let's see if I can find another pair of congruent angles. Yeah, this angle is going to be congruent to this angle. So I'm going to have angle E congruent to angle D because it's also corresponding. Alright, so now from what I learned about similarity, there was three of them. There's AA similarity, SSS similarity, and SAS similarity. I can use the AA similarity, so I can say AA similarity. So that means triangle CEA is similar, not congruent, similar to triangle CDB because of AA similarity. And this is stuff that you learned in the previous units. You're just again bringing it comes back again, and you're applying it to find if your triangles are similar or not. All right, let's go on to the next one. This one, they said determine whether each pair of triangles is similar and justify your answer. All right, so I'm looking at this picture, the two triangles, and I'm going to mark up the ones that are congruent. So these two angles are congruent. So that means if I were to turn it, then that means F is going to be congruent to J, E is going to be E has to be congruent to I, and G congruent to A. But now let me look at the sides. Are they in proportion? So I'm going to use purple. So that means I'm trying to compare this 8 to 10, and then I'm going to make this a box to this. So I'm going to have FE over JI, and is it equal to GE over AI? And I'm going to put a question mark because I have to figure that out if they're in proportion. All right, so now plug in the numbers and see what I get. Let's see if this is going to be equal to each other. I'm going to reduce this. The common factor they have is 2, so that's 4 over 5. And let's see if this does the same thing. The common factor is 3, so that's 4 over 5. Yes. All right, so now I can say that these two triangles are similar. So triangle GFE is similar to triangle AJI because of side angle side similarity. I'll put yes. Again, you have to, once you know that the angles are congruent, now you have to see if the sides are in proportion. That's the thing with similarity. Find if the sides are in proportion, set up the ratio, set up the proportion, the two ratios in proportion, and see if they will give you an equal ratio for both. All right. So now we're going to use this to find certain sides for the triangle. So for this one, it says we need to find DE. DE is X. And they say that the triangles are similar, so that means I can set up the proportion. So that means, okay, so this one is in proportion to, it's congruent to this one. So that means the bottom part of this triangle is going to be similar to the bottom part of this triangle. So I'm going to just do it like this, so that way you know what you need to do in order to set up the proportion. So x over 45 is equal to 3 over 15. And just a reminder, whatever you take from this side and you set it to the other side, you have to do the same with the other one. Same order, same pattern. So it's x over 45 and 3 over 15. And now you cross multiply, so 15x, and then that would be 45 times 3 gives you 135. And that will give you 9. X equals 9. Alright, next one. They want you to find BD and EC, or in this case CE. So they said that BD is, this whole portion is x minus 1, and CE, which I'll put in another color so that way it doesn't get too hairy, is x plus 2. So those two triangles are similar. So that means, and then I'm looking at the sides, so got this, and then I'm going to use, alright, so now this 3 belongs with this triangle with the x minus 1, and then this 8 belongs with this triangle that has the x plus 2. I'm going to set up the proportion. So then 3, 2, 1 minus x is equal to 8 over x plus 2. And then I'm going to cross multiply. I'm going to use, oh my god, let's try that again. Use the highlighter. Make sure I clicked on it. Cross multiply. Alright, so 3 times x plus 2 in parentheses, and 8 times x minus 1 in parentheses. We're going to distribute. Don't forget that. So then 3x plus 6 equals 8x minus 8. Extend the page. And then we combine like terms. So I'm subtracting 8x on both sides. So I'm going to get negative 5x. And then I'm subtracting 6 on both sides. I get negative 14. And then divide negative 5 on both sides. And I wonder if I could put it into a decimal. 2.8. That's my answer. Let's make sure I have everything correct. Yep. Yep. Alright. So again, it's all dealing with similar. If they tell you the triangles are similar, then you can set up the proportion and solve for the variable. Okay. Again, so you're going to see this in word problems. With word problems, you read it first and then figure out what they give you and what you need to find. In this case, they give you a diagram, so you can use that to help you to see what's going on. But if they didn't give you a diagram, you would have to draw it out so that way you can get a better understanding of what's going on. Alright, so it says Nina was curious about the height of the Eiffel Tower. She used a 1.2 meter model of the tower and measured its shadow, which was 0.9 meter. Then she measured the Eiffel Tower's shadow. It was 240 meters. What is the height of the tower? Alright, so she's got her model here. And then she's got the real actual tower there, and everything's set up. So we're trying to see, because this scale has to be, this smaller model has to be in proportion with the real thing. So we're going to set up the proportion. So we have 9, we're going to have 0.9 over 1.2. So I'm going to put it shadow over height. So S over H, shadow over height. And it's 0.9 over 1.2. And then I'm going to use another color to represent the Eiffel Tower. The shadow of that is 240, and we don't know what the height is of the Eiffel Tower. So I'm going to put the actual, and I'm going to use the word model. So that way you know how to set it up, and you can find the height of the Eiffel Tower, and of course, cross multiply. So you're going to have 0.9x equals 1.2 times 240. So 1.2 times 240 gives you 288. And then you divide by 0.9, and then your x will be 320 meters. 320 meters. And that's it. Then same thing which we have been working with, but now we're just applying it to a word problem. Just look for key information, read it first, look for key information, find out how to set it up, and then you get your answer. All right. Okay, so looks like we've reached the end. So a recap, we've learned about similar triangles. So in order to prove that two triangles are similar, you need to show that the two angles are congruent, the corresponding angles are congruent, and the sides are proportional. Not congruent like when we deal with congruent triangles. Similar triangles, we need to have congruent angles and proportional sides. That's what makes it different from congruent triangles. There's three types of similarities when it deals with similar triangles: angle-angle similarity, side-side-side similarity, and side-angle-side similarity. If you do not put that little squiggly line behind that, the SSS and SAS and AA, then you're going to be telling me that the triangles are congruent, and it's not what you're trying to prove. So be careful. With congruency, they don't have that little symbol, but with similarity, there's that squiggly line. And when it comes to solving, to figure out if a triangle is similar or not, set up the proportion. If it's the same on both sides, your triangle is similar. And also, when it comes to just plain solving, if they tell you that the triangles are similar, set up the proportion and solve for your variable. All right. So like I said in the beginning, it's going to be a little confusing because everything that you learned about congruent triangles, now you have to apply it differently for similar triangles. If you still are confused, you know that you can email me and I can help you out, provide you examples, explanation, clarity, so that way it sticks. All right, so this concludes our lesson, and have a good day.